There we go. All right. Let's try that again. Helps so I can spell my own channel name. Yes, this session is being recorded. I don't have a cool YouTube URL yet because I don't have enough subscribers yet. But bit.ly TaleLearnCode YT. That's actually for everything that within TaleLearnCode, but to include all the user group videos. So they'll be up there 1 or 2 days later. Want to thank our sponsors. But sure enough, is someone from Modus here? Because I know they wanted to say something, but I didn't notice any of them dial in. Going once, going twice. All right. So anyway, thank our sponsors. All right. Upcoming meetups. Actually, I've got a lot of links on the Azure side, but next month we will have Corey Weathers talking about building bots with Twilio. So that should be a lot of fun. On the .NET side, actually, I still got to get next month's schedule. But outside of that, I've got a full schedule. So November, we'll have Phil Japiski talking about ASP.NET. December is Jeffrey Palmero talking about Blazor. January is Adam, and I forgot his last name, where he's going to talk about basically how a computer works. So that should be a really fun talk. And then actually in February, and I forgot the name of the person, but Introduction to Identity for Developers. He's actually one of the PMs on the Microsoft Identity team. So lots of great talks coming up there. All right, other groups. Actually, 2 are on hiatus right now. Tech leaders actually should be coming back online the next couple of weeks. But the IT Happy Hour generally is the second Tuesday of the month. Actually, in October, it will be October 6th, which is the first Tuesday. That is because I'm speaking on the second Tuesday, so I can't be 2 places at once. I'm not that good. But also, I tell you, look at other meetups. The benefit of the pandemic is that all these meetups have gone online. So there's always a meetup going on. Definitely check those out. Along with, I'm sure we have folks who come in through the .NET Foundation, and so check that out. There's always great stuff in there. All right, and real quick, my self promotion here. So Monday, Wednesday, Friday at 8 p.m. Eastern, I stream on Twitch at TaleLearnCode. Generally I try to make it very newbie friendly. Where I go through everything I'm walking through. And like tomorrow night, I will be working on some demos for some presentations. So I'll be doing a lot of stuff with Cosmos and getting data in and out of Cosmos. And finally, we can't go to the bar. We wouldn't be able to tonight anyways, because like I said, Louisville's under curfew. But so we'll actually stop the Twitch stream, but then we will have a we'll keep the Zoom going. Hopefully this time I won't kill the whole thing like I did last week. So we'll keep that going. All right, so if you've been attending Louisville.net, you've seen Sean around because once he's there, you never get rid of him. You tell Sean and I talk a lot.
Yeah, and what you said is true.
I don't speak lies.
Yeah.
But sure enough, I was looking for a speaker for tonight, but then he actually did this talk at Copalooza. But now he's actually had to think about how to redo it all over again. Especially because he's been doing more stuff since then. And I thought this was a really good topic because this is something, that's why yesterday he was asking me, well, what do I want him to cover? And I'm sitting there like, dude, I do, PaaS and SaaS solutions with Azure. I don't know how networking works. That's why I do the PaaS and SaaS solutions, because Azure figures it all out for me. All right. But the honest truth is it actually really does help if we have a better knowledge of that. So that's why we'll have Sean talk to us for the next hour or so about Azure networking. Sean, I'll turn it over to you.
Awesome. Thank you. And it's good to know that the first 5 people that you tried to get to speak turned you down and you're left with me. I guess I did pick up on that. So thank you. All right, let me move some things around in my screens so I can share that guy right there. All right. So we are, as soon as this thing actually starts, we're going to talk about and do a, oh man, I'm fighting with so many windows. One second. There we go. Okay. What we're going to do is go through a story about Azure Networking. And then, so it kind of goes in 3 phases. The first one is the story. The second phase is us going through the story again to see if you identified the different Azure networking components. Then on the third phase, the final phase, is when we'll go to the Azure portal and just dive in, go look at several things. I'll show you some code that I use to build out my Azure resources with a library called Pulumi, and how I set up some things to gear up for this talk specifically. And then we'll just go and answer questions, go try out different things, whatever you guys want to tackle. So with that, let's get started. All right. Our story begins at Castle McStone. Hold on a second. I can hear myself.
No, that was me. Sorry.
Okay. That freaks me out. It's bad enough other people hear me. I got to hear myself. All right. So our story begins at Castle McStone. The king and queen were discussing the use of a vacant area of their kingdom. And in the McStone kingdom, there's this large stone-walled structure. It's been vacant for some time, and it was decided to turn that into a marketplace for the people of the land. And here they could purchase various items needed for food, garden, utensils, clothing, and farming equipment. So an architect was hired to, do this right quick. An architect was hired to analyze the structure, the size, the width, the length, etc., and to kind of help lay out where the different people should be for the merchants and the suppliers. So in no time, merchants and suppliers were setting up their different areas. They thought this was such a great idea, so they're going to try this out. And the suppliers, they're in the tents on the far right structure, and the merchants, they form a U shape so that the customers can easily go from booth to booth. And the green dots, they represent the customers, and they quickly started using the new marketplace. They loved the convenience of getting so many various products in just a single location. The merchants also enjoyed the new marketplace. The ability to sell their items in a single location without having to travel so much really helped their sales. And the suppliers that are the ones in these special tents, they sell to the merchants, but not directly to the customers. However, it didn't take long before it was noticed that customers would attempt to sneak into the supplier tents to try to buy the products cheaper. So a guard was commissioned to stop the customers while allowing merchants to enter the supplier tents. And it was also noticed there were times when the merchants would attempt to steal from other merchants. So to prevent this, another guard was commissioned to not allow merchants to go to the other merchants. It allowed the customers to move around, but not the merchants themselves. And they were only allowed to get their material from the suppliers. They were not allowed to go and buy from the other merchants. Now, some of the items sold were animals, and this included killer rabbits. Think Mighty Python. And these killer rabbits were great for defending your property. They are specialized killer rabbits that are flung using a special apparatus, also sold by the merchant. So introducing the Rabbit Flinginator, custom made by DEI. Now, some of the merchants had so many things to sell at one booth that they had a lot of customers at their tables, and it became disorderly at times. And a young knight was commissioned to help form distinct lines. And as a table would become available, that young knight would direct the next customer to that table. Unfortunately, some customers were stealing, and other customers were bringing items into the marketplace that were just not allowed. A guard was commissioned to stop this, and the guard was given special authority. As each customer came in, their bags were inspected for items that were not allowed. As customers were leaving the marketplace, their bags were inspected for proof of purchase of the items they received during their visit. With the increase in customers, there was also a need for someone to help the people navigate their way around. A wise man would stay in a special location, and as customers came into the marketplace, the wise man would direct them to the merchant based on their needs. Well, the marketplace was a huge success. People came from all around to get all their food, clothing, farming, and gardening equipment. And one thing was noticed at many times during the day, there were more customers than could safely fit in the marketplace. It was also found that many came from a faraway land that also happened to be owned by the McStone family. So it was decided to build another marketplace. So now we have two marketplaces, McFar and McNear. Uh, Sorry, hold on. Quick clicking around. Okay. In no time, a new location was created. Advertising began immediately to let the current customers know the new location. But as it happens, not everyone heard of the new location, including some of the new customers. So kids, I mean, knights in training, were charged with letting travelers know of the new location. The young knights would inquire as to where they're traveling, where the travelers are coming from. Then, based on that information, they would direct them to the nearest marketplace. And that ends our tale of the McStone Marketplace. So, what did you learn? Did you catch the little pieces and how they actually interlate to some of the Azure networking pieces? Let's go over that again. Remember the marketplace and how it was laid out specifically for the merchants and the suppliers? The marketplace, that stone wall structure itself, that represents the virtual network. It's a predefined area for other things to reside in. And then inside there, when we segment the different areas set apart for food and gardening and farming and such, those are set up as our subnets. And the subnets cannot exist on their own. They have to live inside of a virtual network. And a virtual network is required to have one or more subnets. And the guards that were set up to keep customers out of the suppliers, well, first off, the supplier tents, those are virtual machines. Those represents, and maybe in our case, maybe they're database servers or a database service of some sort. But we can use a network security group to help govern which traffic is allowed to come into those tents. We can block the customers while allowing traffic that comes from other virtual machines in different subnets. In fact, the merchants themselves, those are different virtual machines. And those two, we can set up using a network security group to govern the traffic in a different way to help protect the different virtual machines in the different subnets. Remember when I said that a a booth was so overloaded with people that it became disorderly, and the young knight was hired to keep people in line and to help load distribute to the different tables as they became available. You can use an Azure load balancer for that. And the wise man that would help direct traffic to the different merchants as they needed to, for the customers to find their way. An Azure route table helps with that. The Azure route table helps govern and control all of the traffic in the subnets that they are associated with. In this way, you can, for example, say that traffic in this subnet, if you're trying to get to another subnet, you can, for example, you can get out to the internet, but you have to go through this door over here. I'll show you that later. Also, the knight with special authority, because we represented knights using that network security group. But here we have a knight with special authorities. And this knight could look at the bags of the customers as they came into the marketplace, as well as when they left. What we're showing here is that by using an Azure firewall or a firewall at all, it can do packet inspection, meaning you can look at the data being sent through the wire and coming in and going out, and be able to validate that that it's safe. And then the knight in training that was helping the travelers know their way around and know about the different marketplace, the new marketplace. Well, you can use either an Azure front door or an Azure traffic manager. The front door is for web apps or APIs, etc., because it's based on the HTTP protocol, and it can use paths and can redirect to regions based on different paths, meaning that you may have another marketplace in our case that's set up, but let's just say that in the first marketplace it has everything available, but in the new marketplace, well, they don't have all the garden stuff set up yet. Well, if a traveler is specifically needing to go to garden, then they need to go to the one marketplace that has that available. Else they'll end up in a spot where it's not available and still having to go travel to the other spot, the other marketplace. So you can use paths in the HTTP traffic to help control which region, which Azure region you want them to go to. And the traffic manager, the Azure Traffic Manager, it uses DNS to redirect traffic. But the nice thing about the traffic manager is that it can use any protocol. It can use HTTP, but it can also use TCP and UDP, which also means that you can use TCP and use a different non-standard port. It doesn't have to be port 80 or 443. So I talked about the virtual network with subnets. Well, this is what I used in my example that I'll show you in just a moment, that I set up my virtual network address space to use a /22. This is called CIDR notation, CIDR, the classless interdomain routing protocol, or notation, I mean. So I'm using the 10.0.0.0 just as a basic example. And it's one of the internal IP addresses that you get in Azure. And by using the /22, it allows me to have 1,024 addresses. And each subnet is set up so that it's using out of that address space a /25, which limits it to 128 addresses in each subnet. So a little bit more about CIDR notation. Unlike binary masking, which let me cover that first. With binary masking, the bits the ones and zeros can be in any place they need to be. But with CIDR, that's not the case. With CIDR, the ones are essentially, like looking on the screen, are left to right. And looking at that top line where it's the /22, you notice that where the ones stop and the zeros begin, the ones indicate the network, where the zeros indicate the hosts. And as we go from a /22 to a /23, then you notice that the one digit has increased and the number of zeros has decreased. Essentially, it's in half. And as we increase the CIDR notation one more time to /24, we're in half once again. So it goes from 1024 to 512, 256, 128 to 64. And I think the tightest, you could do a /32, which means you get the one and only IP address. Now, to actually do a subnet or in sort of an address space for this, that the smallest you can get is a /28, which is going to be 16. So this is something that I had to spend some time wrapping my head around until it just finally clicked that I was familiar with binary masking. In fact, I've been doing binary masking and understood binary since playing with electronics as a kid in my teens. But with CIDR, the trick is that when you're laying out the bits, it's left to right. And that's why it's immediately in halves, meaning you cannot have a subnet that's 513 or 514. You cannot do that. It must be on the binary lines. So when I built this out, I have my virtual network with the subnets, and then I made 5 different subnets. So I have my supplier subnet, and it starts at 10.0.0.0/25, and it gives me 128 addresses. And it goes from the 0 through the 127. Then the next subnet, I have it stacked on the very line so that the next address, the 128 through 255, that is the next subnet for food. And so on. And then as you see that the highest you can get is obviously 255 because you can only do 256 in an octet. Now, obviously this is all IPv4. IPv6 is a whole nother topic for a whole nother day. So now that I've finished out the 4th octet, I need to increase the 3rd octet. So now it goes from a 0 to a 1, and then I can start over. So now in the 10.0.1.0, I can start from 0 through 127 for clothing, and then I go from 128 to 255 in farming. And then I needed one more subnet, so I added on, and now, but since the .1 is full, I have to increment that and go to .2. You kind of see where this is headed. Now, there's a little detail on this about how Azure treats subnets. Now, first off, without Azure, if we're just talking about network, you cannot have a computer that sits on a .0 address, nor can you have a computer that is listening on a .255. And the reason why is that the 0 and the end, the 255, those are used on special purposes. They are essentially reserved. So you're already 2 IP addresses that are out of that picture, out of that count. So although we may say, yes, /25 gives you 128 addresses, in reality, it's 126. Now, here's the Azure part. There are 3 more IP addresses that are also reserved. So the .0 and the .1, 2, and 3, plus the .255. Now, sort of. Let me get to that. I'm mentioning .0 and 255 because it's kind of really easy to wrap our heads around first off. The .1, that's the gateway address for that subnet. meaning that all the virtual machines that you have running, when they need to get over to another subnet, they first route over to the .1 address, and the Azure supplies a gateway of sorts so that all the traffic that's going to go to another subnet, even into another VNet or out to the internet, etc., those go out through the .1, that gateway address. Now, I don't remember off the top of my head what 2 and 3 are used for, but the 255 is a broadcast address. Now, here's the rule that we got to remember when we deal with subnets. Every Azure subnet takes 5 addresses. So we can say it's 128 addresses, but it's actually 123 available for virtual machines for other use, be it private endpoint or something to that effect. The other 5 are not available. Now, I did say 255, but I also said out of our supplier's subnet that it takes 5, because it's not just 0 and 255. It's at the beginning of the subnet and at the end of the subnet. So for suppliers, it's 0, 1, 2, and 3, and 127. Those are specially reserved. So you can start with a .4 and go to 126. Then we go over to the next subnet, 128, 129, 130, 131, and 255 are now reserved. So hopefully you kind of see what I'm saying, that every subnet, the first 4 are reserved and the last one is reserved. Okay, if I haven't confused you enough, let me stop here because I'm about ready to show you some other Azure resources. So before I continue, any questions? All right, seeing none. So let me do this first. Before I go and show you some of the Azure resources, I do want to give out a special thanks to David Neal, Reverend Geek, and VectorPocket, and BRGFX for providing me with some of the graphics that I used in this. Okay, and I mentioned that first because it's part of the recording where jumping out to the Azure resources and stuff, we can spend a lot more time on that. All right, so let me jump out of here and pull up my portal. And this is the part now where I'm going to show you several things. And I have a Azure resource group built out, and I've got a virtual network with a great name. You can tell it's named by a programmer, VNet1. And in my virtual network here, I have got it set up, and you can look at the address spaces. It's a /22, gives me 1,024 addresses. And I can look at my connected devices, and I can see the IP addresses of the different network cards, network interfaces, and the load balancer that I have set up. And then I've got my subnets right here. And you notice that I said 123 available. Out of 125, there are 5 addresses that are already designated, pre-designated. So you only have 123 available. Now, in my case, the Azure firewall and the app gateway subnet are actually for another use, but I left those in for right now. The clothing, farming, food, and garden and suppliers subnets are where the different virtual machines reside. Excuse me. And you can tell with food that 123 available, meaning that there's already 3 taking up. So now that I've got a virtual network and I've got my virtual machines set up here, let's do this. So I've got my 3 suppliers. And thankfully, Azure Mask is working. And so I've got my virtual machine that I've also told it to not have a public IP address at all. Instead, it uses and grabs a private IP address that is, it pulls out of the designated subnet. So in my case, it's pulling from the VNet's virtual network, VNet1, and the supplier subnet. And I believe, if I remember correctly, I'm just using a standard B1MS. So the accelerated networking is not available. But I will say, if you're using like a D series virtual machine or an ERNF, those, I believe most of those, not all of them, most of those you can have accelerated networking enabled. Do that. Have that enabled as wherever you can. The difference is that Azure has what is called a layer 3 overlay, meaning this is not the IP address you think it is. So although it thinks it has the private IP of 10.0.0.0.6, it's told that it has that address. So the layer 3, which is in the OSI model, is where the IP part of the stack is at, versus layer 4, which is TCP. So this virtual machine has a virtual IP address. And there's also a bit of kind of a software piece that Azure has that is in the way. So if you use accelerated networking on those virtual machines, you get to bypass that. And you might see nanoseconds of efficiency there. It's not drastic by any means, but if you're going to do high volume, very time sensitive things, you want accelerated networking to be enabled. All right. So, and a virtual machine can have more than one network interface, and you can have one, obviously one has to be primary. And I also have a network security group that is set up. So I already have things governed right here. And this being a supplier, one of the suppliers, the tents that I showed you, this is saying that in my network security group rule that traffic from the food subnet coming into the supplier subnet here using on the TCP protocol, we're going to deny it. And I said, we're going to block access to suppliers by the food merchants because, and maybe in our quick example, well, they don't supply for the food. So there's no reason for them to have traffic there. There's no reason for them to be allowed. Whereas the merchant traffic here, we can say that traffic on these different subnets, they're allowed to come in on port 80, but not just any port. We could change that to a star or an asterisk, and we could leave that open to any port, but we can also narrow that down to a range of ports as well. So we're able to control that access through the network security groups. And then the virtual network to virtual network this is what allows other things in the virtual network to talk to each other. Kind of think of it as this is what allows the customers to talk to each other. And these 65,000, the 01 and the 65,500, these three here are there by default. In fact, you cannot delete them. You can override them by being at a higher priority, where the priority starts at 100. That is the highest priority. If I did a deny all, which is what this bottom one does, if I created my own deny all and put this at priority 100, then nothing would work, as nothing would be able to fall through. I can also control outbound rules, outbound traffic from the subnets that it is attached to. So if we look at a network security group, I know we're quickly looking at the different rules, but I can also associate a network security group to both subnets and network interfaces specifically. And in my case, I have the network security group set up so that those are those guards. So imagine you have one company, one guard company that is supplying all the details. And I have it associated for the clothing merchants, the farming, food, garden, and suppliers. This also means that you can set up rules, and if they are not associated to a subnet, it won't work. There's one more thing that I could do in here. And let me choose an IP address, and I'll choose all zeros /0. Now, although I could do that, I could also use service tag of internet. Either one would work. What I'm saying here is that if the source is the internet and the destination is something very specific, or any in this case, and we'll say any port. So now anything from the internet on any protocol here will deny it. Let's put that at 100. And we'll change our name and we'll say block internet access. Now, doing that says that any access, this would say like those customers, we just shut the door on them. Now, none of the customers are allowed to come in. The marketplace is closed. The only problem with this is there's not an enable and disable with the rules. They either exist or they don't. So as much as I like the network security group and the rules that they have, I really wish that they would have a way to enable and disable without having to delete just to re-enable this. Now, as well, you can attach a network security group specifically to a network interface. And remember that I said a virtual machine can have more than one network interface. In fact, something I've done is created a custom virtual machine that is a firewall using custom software. And that has 4 different network interfaces for 4 different purposes. So I can attach a network security group to one of the network interfaces, but not affect the others. Okay. Let's see what else we should talk about. So those are virtual machines, and we talked about the network security group. Now, the difference between a network security group and a firewall is that a firewall does packet inspection where a network security group does not. Now, remember the wizard that was helping people be able to move around and know which merchant to go to? Well, that is a route table. And you can see that I also have this associated to all of the subnets, but I don't have to have it associated to all of them. But if I want it to work on that subnet, it must first be associated to it. So what's happening here? This is saying that any traffic that originates from one of these subnets that is headed towards this address, which happens to be the internet, that traffic is forced to go to a different address. Now, I don't have it set up in this case, but I would set up it like an Azure firewall, or maybe the other firewall I just mentioned that's running on a VM with 4 different network interfaces. This would point to the address of one of those network interfaces. That way, all of the outbound to the internet traffic goes through a firewall to see if it's allowed to go out. All right. Now I'll tell you what, there
Sean,
aren't.
I have a
Yeah.
question.
Hi, Randy.
Hey, how are you?
I'm well. Go ahead. What's your question?
Um, so I was waiting to see in the route table if there
Yes.
were routes between the subnets, and there don't appear to be.
You
So
don't you don't need them.
that's what I was asking. Okay.
Yes. And the reason why is because in the network security group, if there is one applied, you have this virtual network source and destination. And that is what is allowing them to go around to the different subnets without special provisions, I should say. Now, I could, with this being attached, the network security group being attached to the subnet, I could add a provision that denies it, or I could do various things. Let's see. Now, if there's not a network security group, then I believe this is open anyway. So by default, the subnets can talk to other subnets.
But yet they can talk. But how? Where is the routing that tells someone who's in, say, the food merchant
Uh-huh.
subnet? How or who
How,
is setting up the routing so the packet
okay.
knows how to get into the merchant
Hmm.
subnet or into the
Okay.
supplier subnet?
In the subnet, you mentioned, like, say, food, wants to, the virtual machine wants to contact another virtual machine in a different subnet. It actually goes the traffic goes to the dot one,
One, yeah.
which it goes to the gateway address of the subnet. And Azure is doing the, for lack of a better word, because it's really not a router per se, but it is routing. And meaning it's not it's not natting, and it's not
Right.
doing padding, but the governing of that is at the gateway address of each of the subnets.
Okay,
So the
so the
virtual
gate,
network is,
yeah, so the gateway then would know
yeah,
how to route into another subnet of this VNet.
yes,
Okay,
yes, it
cool.
does. The VNet and essentially, excuse me, yes, the VNet takes care of that, and by the traffic first going to that gateway address.
Okay, thank you.
You bet. Um, all right. So when I've built this out, you can see all of the okay, yeah, let's do this. So I've got two food virtual machines, because we can say that I've got my garden and I got three suppliers, but the food, well, as it happens, you could think of it as a at the fair, right? The state fairs, that you've got a lot of food vendors, and maybe there's a food vendor that's, it's doing really well. They sell a lot of great food, and you can set up an Azure load balancer to help balance the load between the two virtual machines. And I have it too, that it has a private IP address. What this is saying is that this is a private load balancer. The difference being that if it was a public load balancer, it would actually have a public IP address. And for certainly for a lot of the stuff that I do, every public IP address is a point of attack. So I want as few of those as possible. And since I just need a load balancer to that's inside my marketplace as such, I don't need a load balancer that has a public access. So I've got a internal load balancer here. And I can look at my backend pools and I can see the different virtual machines that it's attached to. Now, the interesting thing too about this is that the load balancer is not attached to the virtual machine. The load balancer is attached to the network interface of the virtual machines. Why do I say that? Goes back to my other example where I've got a custom firewall loaded on a virtual machine that has 4 network interfaces. Well, I can pick the network interface that I want of the two different virtual machines if they have more than one. And you'll have more than one for different split purposes. And in my case, I have one network interface on across 4 different subnets. Okay, so with the Azure Load Balancer, and I know this is something that Randy would be interested to know. This is round robin. There is not yet a way to be able to for different load distribution models. If you used I'm sorry?
Boo, hiss.
I agree. I completely agree. If you use a virtual machine and you load Pulse Secure software on there and have it be your load balancer, you do get 5 choices for load distribution models between weighted least connection and weighted least connections and other besides random and round robin. And so the other thing about that's kind of a misnomer about round robin is it will not go 1 2 1 2 1 2 1 2 1 2. That would be nice. But instead, if you were to sample it over time, you would see that the average is about 50%. 50% one way, 50% another. But what you may have is traffic going to, let's use the numbers on the virtual machine. We'll go from, it goes from 0 0 1 1 1 0 1 0 0 0 1 0 1. You can see, you kind of pick up on that mix where it averages to be 50%, but you're not guaranteed a true switch, which also means you could still overload a system before it actually balances out properly. Well, then you set up a health probe, and kind of wishing I'd set one up already, but you can set up a health probe to help determine if a system is actually getting overwhelmed. You can use TCP or HTTP and even have a path. So if you have something like an API, you could set up a custom API health check, and that endpoint is specifically for the purpose of the health check monitoring by an Azure Load Balancer. Which also means you could set this up so that only the Azure Load Balancer is able to get to port 81 in this example, and no other traffic. So I go to my network security group, add a rule in front of my food virtual machines in that subnet, and say, if you are coming in from the Azure Load Balancer IP address, which it has one that's stated, I don't remember it off the top of my head, it's 169 something, but it's documented. But traffic for the health probe actually comes from a known documented IP address. You can put that into your network security group rule and say that if it's coming to port 81 from that Azure Load Balancer, that's allowed, but nobody else is allowed on port 81. You could. All right, so then I got load balancing rules. This is where I'm trying to help it understand. Why am I being told this? Oh, because I don't have a probe. So yeah, that you have load balancer rules are supposed to exist without a with a health probe. And the way that I set this up, it didn't stop me. So it was not through the portal. So what this is doing, after giving it a name, I'm going to do IPv4, and I have a front-end IP address, which is just to be that one private address now. You can add several different front-end IP addresses, which also means that you can have a public load balancer that is serving multiple public IP addresses. And you can help govern which way they go. And this is saying that traffic coming in to this .132 address on TCP port 80, you can also do padding, port address translation. I can say you're coming in at port 80, but you're going to go out 8080, something like that. And then I can pick my backend pool, being the different virtual machines that I've already set up. You pick your health probe and then your session persistence. The session persistence is the client. You either have none, so there's no persistence, or it's client IP, and the other option is client IP and protocol. Those help you with the next traffic coming in. This is stateful, meaning that as traffic comes in and it gets routed to a virtual machine, when you are done, that traffic, the reply, the acknowledgement on the TCP level will return the way it came in. So that's stateful. What the session persistence is for is the next call coming in to that load balancer. You can have it set up and go, well, wait, I already recognize this IP address and it was pushed over to this other virtual machine. I'll let it continue that way. All right, let's go here. Inbound NAT rules. I don't have one set up. If I wanted to bypass a rule and have it come in and just say that if you're coming in on, say, port 22, you are specifically you're going to a specific target on that port. And so it's not so much of a load balancing rule as it is a specific network address translated rule. Why would I use that? I've used it for going to a management access of something that was running on a virtual machine. And so I could have it specifically going to a port. So listening in on that IP address, very many options as far as services. Let's say SSH, so it's port 22. And I pick my target. Let's just say it's the first of the food. You notice it's not all of them, so it's not a load balancing rule. But this is saying that traffic coming in to this IP address on port 22 will go specifically to that one virtual machine. Why would I do that? Like I said, you can do that if you have a designated virtual machine for maybe configuration management or something. If you're thinking, well, I still like high availability and I want that low distribution, you're going to go with a inbound rule, a load balancing rule instead of an inbound NAT rule. Okay. Let's get out of here. And please, as you have questions, let me know. Let's see what else is good to show you. What I can do is show off a little bit of code that I used to create all of this. And I created it in, where did it go? Yeah. So I created most of what you're seeing in that Azure portal in under 4 minutes. So I'm using a thing called Pulumi, and of course, as demos work, right before when you need to run them and set things up, they always have a little failure someplace. So using this code, I was using, which is Pulumi. This is called infrastructure as code. And I know this talk is not for Pulumi, so I want to just touch on it very, very briefly. But this code, which is using a library, and I'm able to use C#, I'm able to set up a script-like manner and set up my virtual machine, my route tables, my subnets. With the route table, I have my subnet route associations, my network interfaces. I can set up my backend address pool for my load balancer. There's my load balancer rule, and I set up the virtual machines. 1, 2, 3, 4, 5, 6, 7, 8, at least 8 virtual machines simultaneously. That's how I was able to build out so many things in less than 4 minutes. So this is Pulumi. Like I said, it's a library that is free and open source. I can say I want a new resource group, and then I want to go and build my virtual network. And this is where I have it set up, and I want my 10.0.0.0/22. So I have my 1024 addresses. I want to have a subnet that is attached to this VNet. And you can see how I put the /25, and I put the comments in here to help me remember, certainly for talking about this detail here, is how many addresses that they use. So I set up my virtual network and my subnets through here. All right, let me minimize that. And then I've got my my virtual machines, and I even have it set up so that one version is without an availability set and one version is with an availability set. So this is what's kind of neat. I'll show you this. As I'm building a virtual machine, I've got my network interface, and you have to have it first because that's the only way to have a virtual machine cannot exist without a network interface. So there's my virtual machine. You notice that the VM variable is not used because it's not, unless I need to persist it, I don't need it. Meaning that when I run this, I actually don't run through Visual Studio. I run it through the CLI. So what I did, let me go up here and find Pulumi up. And I created a new stack called dev, and it actually compiles my code and then looks at the output of the code and then builds Terraform information. And it's leveraging Terraform. And it does not create TF files that I'm aware of, but it does leverage Terraform. And it builds out a plan of what it's to do, either to create, modify, or delete. And then I said, yes, I want you to go and continue. And it starts cranking through and created my resources. So if I was to, for example, and go, this is not a B1MS. Let's say, if just for giggles, let's say it's a DS _V2. In fact, now I need a number there. Let's say it's a DS4. All I got to do is save, rerun Pulumi up. It will go and see the difference. And now, in the fact that I put that in the build VM, that would actually affect every one of my virtual machines and change them out and resize them from the B1MS to the D4S V2 SKU number. So anyway, I used Pulumi to build out all of the resources here. And something that I've been playing with outside of this is I have a script set up. It builds a virtual network. It builds 8 different subnets, 20 virtual machines, 3 of which are SQL Server. It builds 6 different Azure load balancers and configures them and associates them, plus a route table, plus NSG, plus proximity placement groups, etc. And it runs and builds everything in less than 10 minutes. I love that. Absolutely loved it. I showed that to my boss today. He was excited. So, all right, guys, I think we're about time. So please, any other questions? And I will be able to, answer them. Let me know what you think. One other detail that I did forget about network security groups. Let me point this out right quick. This network security group is associated to, say, food. And we know that the food subnet has 2 virtual machines. If I was to come in and say, like, let me add a rule here, and yeah, 220 is fine. Let's say, now I did forget, so let me go back to food. Is that right? Let me see if it says, okay, food is that I wanted that address range. I don't have all this memorized. I'm going to do a new rule that says if you are from, actually, I tell you what, let's do this anywhere. Let's do any, and you are going to to the food subnet, and it doesn't matter because for what I'm doing, it doesn't matter. So on the port, so I'm going to say star ICMP, and I'm going to say deny. I'll say deny ping to food merchants. Okay. This is an interesting rule because this network security group is applied to the subnet of food, and there are 2 virtual machines in that subnet. This rule says any traffic that's trying to do a ping into that subnet will not be allowed. All right. That means nobody can ping those 2 virtual machines. Here's the catch. That also means that the virtual machines themselves, the 2 food merchant virtual machines, ping going between the 2 is also affected. They cannot ping each other. So here's what I'm trying to say, that a subnet is not like a ring that is going around the virtual machines, and that if you apply a network security group on that subnet, that somehow it's protecting those virtual machines. It's not doing that. In this case, what is actually happening is that the NSG is basically affecting the traffic on every network interface that is associated to that subnet. So in that case right there, what I said, deny pings, that even means between the 2 virtual machines. They will not be able to see each other. So what would I have to do to preempt that and allow it? I would create a rule at say 219 or 215 or something, so that it has to be before this one. It says, if your source is the food, in fact, let's just do that. If you are a food coming from there, going to food, and you want to be able to ping, we'll say allow food to ping. Okay. We'll allow them to ping each other. Now, I have to be a higher priority, a lower priority number, so it's a higher priority. I'll put it that way. It has to be in this scale here. I'm just going to be ahead of it. So now I'm allowing ping to go between the virtual machines in that subnet, but nobody else can ping them. If this was the other way around, where this was, say, 221, and I tried to ping, then it would fall into the any is denied, and that rule applies first. So I did a little preemptive rule that says, well, I do want them to see each other, so I do allow it here. Now, some of you know where I work and know what I work on. One of the things we do is there are times when we need virtual machines to be able to communicate because they are clustered together and they need to communicate. So we actually allow them to communicate, but we also restrict it tight enough so it's only on the different ports that they're allowed to talk to each other. Our web servers, for example, the web servers are never allowed to talk to each other. Why? The reason why is because what if there was rogue code that got in, or a hacker got in, something to that effect? There's no business reason for any traffic to come from one web server to another. So we even control using network security rules and firewalls and such, so that we govern the traffic even inside our VNet, let alone the extra perimeter controls that we have in place. Even inside that VNet, even inside the different subnets, we control that traffic so that we have as tight a control as we can, so that we have the best security in place as we can, as we think this out. This is why I would look at this and understand the different rules. And this is also why I brought it up, because I've seen that before. I've got two virtual machines and I need to be able to ping across. Why does this not work? Because of how it is associated to the network interfaces of the subnet that is associated to. Hope that helps. Any questions? Let me do, no, I didn't say at the beginning. Sorry. Well, this is gonna be fast. I didn't mean for it to start at the beginning.
Well, why'd you do that?
I don't know. I'm talented, very talented. All right, that's even so slow. I don't even know why it's doing that. Okay, we might get there. That's PowerPoint for you. And stopped. Okay. Let me see if I can do. Let's see. I think it's this one. There we go. All right. So thank you all. Appreciate it. Thank you for having me, Chad. I hope this was helpful and some decent explanations to at least get you started into Azure networking. And I'll be available after this to answer any other questions that come up. But my name is Sean Whitesell, president of the .NET user group in Tulsa, Oklahoma, Microsoft MVP, and I'm a cloud architect at TokenX. We deal with encrypting and securing credit card information. That's why I mentioned that earlier. And I got some Twitch friends, one of which you may know, TaleLearnCode, and I'm on Twitch as well. In fact, I've been doing several streams of actually using Pulumi for this presentation. So if you'd like to learn a lot more about Pulumi, you're welcome to check out those videos or contact me and we'll chat. Thank you, Chad.
I know. As I watched this, I just thought of, I'm just glad I'm an app developer.
Yep.
Again, I just, when I do stuff in Azure, I get to the networking tab, I just say next.
Yeah. And this is what I do. I have to think that kind of stuff out. What is allowed to talk to each other? What is not allowed to talk to each other? As much as we want traffic from our customers across the internet, there is traffic across the internet that we don't want. So we have to check for that. We have to understand, what does Azure provide as far as basic DDoS protection, and what do they not provide? What do we need to add? That kind of stuff. So anytime you're going to do in Azure, well, in any kind of cloud framework, be it public cloud or private cloud, you need to understand where your perimeter exists, your defenses in depth, your strategy on that. There's a lot to it, and I absolutely enjoy it. I love it.
Awesome. Well, any questions before we end the Twitch stream? I know on the stream they've been pretty quiet, although a lot of our normal folks are on there. Curious Drive was on there.
Awesome.
McDermott was on there.
McNerdius.
McNerdius, yes, thank you.
Yep.
All All right. Well, sure enough, I'm going to end the Twitch stream. But what I'm going to do is, since our friend TBD Gamer is on, I'm going to. I've never tried to raid.
It's /raid.
I know how to do that.
Yeah.
I never tried to do this while I'm broadcasting from Zoom. We'll see if.
Here's a quick thing though for all the visitors. If this accidentally closes the stream, come back on.
Yeah. Well, I think I know what I did wrong there. All right. So
okay. All right.
So again, for those on Twitch, I'm sending you over to TBD Gamer. Definitely say hi for me over there, and hope you join me tomorrow. See y'all.